the Great American Eclipse. On August 21st of this year, a total solar eclipse crossed the United States in what has been called the Great American Eclipse. It went from coast to coast across the United States and was the first eclipse in American history with a path entirely in the U.S., which is how it gained its title of the Great American Eclipse. The path of totality began in Lincoln Beach, Oregon, and crossed about 14 states before ending its journey on the East Coast near Columbia, South Carolina. The eclipse was expected to take around 90 minutes to travel from the West Coast to the East Coast, with totality only lasting for about 2 minutes and 40 seconds at any given location along the eclipse's path. To understand why the Great American Eclipse is such a big deal, we first need to understand what a solar eclipse is. A solar eclipse occurs when the moon passes between the Earth and the Sun, blocking out the rays. During a partial solar eclipse, only a portion of the sun's rays are blocked from view, leaving some of them visible. But in the case of totality, or a total solar eclipse, the moon covers the entire face of the sun, blocking all of its rays to the Earth. Due to the eclipse being such a major event, people wanted to make it a point to experience this event in every possible way. People were flooding into cities of totality by the thousands. There were many predictions about how this would affect the traffic, local infrastructure, and human health, especially in areas of totality. It was estimated that roughly 2/3 of the nation's population live within about a day's drive of a location of totality. The Federal Highway Administration was expecting anywhere from 2 to 7 million travelers to travel leading up to and following the eclipse, thus leading to one of the nation's largest occurrences of mass migration for a natural event. Though these were not the only predictions, and early estimates put the number of travelers at least 25 million, according to NASA's representatives. This map shows an estimate of the drive time for all of the U.S. to a point on the eclipse path of totality. So each state shows how much time it would take to get to a point of totality. With such wide margins of possibility, many were unsure what to expect. Based on information surrounding the daily traffic patterns, increased hotel prices, etc., the FHWA warned travelers to expect delays, especially as they reached major cities where roads converged. For those following the aftermath, a clear path of totality was obvious by the display put out on Google Maps pictured here. The map provides a view of all the areas where traffic slowed due to visitors leaving viewing spots around the country. The pattern that formed matched that of the eclipse as it moves across the U.S. As you can see, the traffic is located along the path of the eclipse, along the path of totality to be exact. As massive as this event was, some towns and cities began prepping for it as much as 18 months before the event. For those towns lucky enough to be in the path of totality with hefty budgets, consultants were used to help plan for population control, traffic congestion, and tourist demands of the local infrastructure. Many of the areas affected by the eclipse, though, were small towns and cities that were not equipped to handle thousands of people in a single weekend. And in most cases, the estimated figures far exceeded the number of annual visitors expected in the area. This mass influx of people created a lot of congestion on roadways. And in Colorado, the state had to even halt road construction and prevent oversized and overweight vehicles from traveling through the state on the day of the event. In some parts of South Carolina, traffic patterns increased by over 200% from the normal volume in the area. Drivers were stuck for hours in bumper-to-bumper traffic. And in some places along I-95, State Highway Patrol were closing rest areas because they were way above capacity. Gas stations along the path of totality were even running out of gas and were forced to ration out the amount a person could purchase. That way they could continue to serve the area motorists. As a result of the mass migration of our population, tourism along the path of totality was expected to skyrocket. Almost all of the hotels were booked out, some even as far back as 4 years ago. Price gouging and special event pricing was a rampant trend in these areas and was especially common when booking a room on or around the eclipse's path. Many of the towns that reached totality were relatively small towns with limited resources and limited pre-planning for visitors. But most of the towns saw this as an opportunity to make an impression on tourists coming in. Cities as small as Glendo, Wyoming, which has a population of about 203 people, estimated that they saw 70,000 to 90,000 visitors to the area and surrounding parks. Many cities expected an immediate impact on their local economies from the sale of eclipse-related merchandise, accommodations, and food-related items. The major city of Nashville estimated that 90 to 100,000 people visited during the eclipse, generating an estimated $28 million. Kentucky also estimated around 100,000 people visited, but estimated they accumulated around $30 million. While the official tally of economic impact is still under review, most feel the eclipse was a positive financial impact on their town or city. Another main concern surrounding the eclipse was about human health, and more specifically, eye health. Viewing the solar eclipse without safety glasses could seriously damage your vision. One optometrist equates the damage to using a magnifying glass on a leaf to amplify the sun's rays. Depending on the sky conditions, it only takes around 90 seconds to damage your eyes permanently. And damage is cumulative, meaning that even if you look at the sun for a few seconds and then look away and then look back, you're not saving your eyes from damage. The damage accumulates with each view of the sun. Looking directly at the sun with the naked eye can damage the retina, the light-sensitive part of your eye, basically cooking it. According to Dr. Christopher Quinn, president of the American Optometric Association, if the exposure is great enough, that can and will lead to permanent reduction in vision and even blindness. While this is scary, medical reports have been looking very positive, with little to no increase in visits to the... Doctors say they credit public health warnings for the lack of injuries. While eye injuries do not appear to be on the rise, doctors did see an increase in fractures, sprains, and minor lacerations related to falls while wearing eclipse glasses. Many eclipse viewers were so busy looking up that they forgot to pay attention to what they were doing on the ground. While millions were enjoying the show the eclipse provided, others were collecting data to study after the eclipse had passed. During a total solar eclipse, we can view the outermost atmosphere of the sun, called the corona. Usually the corona is not visible due to bright light from the sun. However, during a solar eclipse, the corona becomes visible just around the corners of the moon. Thanks in part to the program CATE, scientists were able to capture a total of 4,500 images of the sun's corona during the 93 minutes of the solar eclipse. The combined images allowed scientists to view how the sun's corona changes over the entire 93 minutes of the solar eclipse. Within the collection are new and never-before-seen images of the sun's corona. Scientists are interested in studying the sun's corona so that we may better predict the occurrence and magnitude of solar flares that may disrupt technology on and around Earth. The study centers around coronal mass ejection of massive clumps of charged particles. These charged particles can cause disruptions in technology when they impact Earth's atmosphere. By studying the corona during the Great American Eclipse and viewing how the corona changes over the length of the event, scientists are able to test existing models and determine if the predictions made from those models are close to being accurate. The ability to view the complete event gives scientists the ability to refine predictive models so that future predictions are more accurate. Many flares are directed away from Earth and pose no threat to our way of life. However, experts anticipate at least one major solar flare impact on Earth per century. This image shows solar material erupting from the sun's surface, also known as a solar flare. Predictions regarding mass migration, tourism, and economic returns were based on a best-guess scenario this year and remained fluid leading up to the event on August 21st. Despite the challenges, many of the predictions were accurate and provided a positive result along the path of totality. Cities benefited from the increase in tourism, spending, and awareness of their offerings. Technology allowed for the spread of information regarding viewing parties, traffic expectations, and public service announcements regarding eye health. The next coast-to-coast solar eclipse is just a few years away, 7 to be exact, in 2024. And the lessons we learned from this year's eclipse will be carried on to the 2024 eclipse, and so on and so forth.
The Great American Eclipse of 2017. A total solar eclipse is when the sun, moon, and the earth all line up so that the moon completely blocks the sun from one's point of view on Earth. The moon has to be between the sun and the earth for an eclipse to occur, and the lunar phase when this happens is during a new moon. The most recent total eclipse since one in 1979, which passed across the U.S., happened on August 21st, 2017, and was the first eclipse to stretch from coast to coast in 99 years. The media named this event the Great American Solar Eclipse. The path of totality, the path across the United States in which the moon completely covers the sun, stretched all the way from Oregon to South Carolina. The path of totality spanned roughly 70 miles in width. The path of totality, the path across the United States in which the moon completely covers the sun, stretched all the way from Oregon to South Carolina. The path of totality spanned roughly 70 miles in width. Thousands of people traveled from near and far to be in the path of totality to witness the full eclipse. The full or total eclipse lasts a maximum of 2 minutes and 40 seconds. Everyone else in the United States not in the path of totality experienced a partial eclipse ranging from 48 to 97% lunar coverage of the sun. This is a picture of the path of totality that stretched across the United States. The total solar eclipse passed over Georgia in the northeast corner. The shadow of the moon first touched Georgia at 2:34 p.m. and left the state at 2:40 p.m. Forecasters predicted changes in the weather due to the eclipse. Some of the changes would only be noticeable to meteorologists, while others would be noticeable to humans and animals. One example of a major weather change during the eclipse is the drop in temperature due to the sudden loss of sunlight because of the moon has blocked the sun. The more cloudy it is in the sky, the less the temperature will change. Also, the time of year will factor into how much the temperature changes. During the solar eclipse in 1834 in Gettysburg, Pennsylvania, the temperature dropped 28 degrees. During the Great American Solar Eclipse of 2017, the temperature was predicted to drop from 5 to 15 degrees in the direct path of totality. The National Weather Service also states that the temperature in Douglas, Wyoming dropped 11 degrees. In this graph, you can see the drop in temperature. A solar eclipse can change the way the air moves. An eclipse wind is the change in the direction the wind moves due to the moon covering the sun completely. When the sun disappears behind the moon and the air cools, warm air stops rising from the ground, causing the wind to drop and change direction. As soon as the sun comes back out, the winds return to normal. In the path of totality, winds were recorded to fall just over 2 miles per hour and change direction in about 20 degrees. Even more rare than eclipse-induced thunderstorms are tropical cyclones. If a hurricane or tropical storm was already in the path of the solar eclipse and was sitting there long enough, the hurricane could have a reaction to the loss of sunlight. Although storms get their energy from warm ocean water, the heat from the sun could have an impact. A solar eclipse can also cause plants and animals to alter their natural behaviors. Interestingly, plants, which rely on sunlight for photosynthesis, had behavior changes during the Great American Solar Eclipse. Flowers such as morning glories and hibiscuses, which usually close during the nighttime, close during the darkness of the eclipse in the path of totality. When the light reappeared, the flowers opened back up. In this picture, you can see the flower closing and opening as the light changed. The eclipse minimally affected pets such as dogs and cats because they live on human schedules as opposed to schedules driven by nature. Dogs and cats may have been a bit spooked by being in large crowds if brought to the path of totality with their family. Just like humans, if the cats or dogs looked directly at the sun, they could suffer from eclipse blindness. While experts shared that it is not necessary to outfit pets with eclipse glasses, many pet owners protected their pets with special viewing glasses as a safety precaution. The most unusual effects of the eclipse happened to insects and birds. Right before the eclipse occurred, cicadas and other insects got extremely loud, and then at the moment of totality, they became eerily silent. Birds changed their song patterns, and some birds flew in huge formations. Fishermen reported that the eclipse affected their catches. As totality approached, morning feeders like bass thought it was early morning and bit onto the fishermen's lines because the dark skies confused them. Bellingham Bay in Washington reported that a big tide caused by the eclipse caused the net that was penning salmon on a fish farm to be ripped open. 305,000 Atlantic salmon were washed to the shore because of the eclipse. Nocturnal animals such as bats and owls woke up because they thought it was nighttime during the total solar eclipse. The bats began hunting and the owls began to hoot. During previous eclipses, certain orb-weaving spiders began to disassemble their webs during totality because they normally take them down in the evening and rebuild them in the morning. Mosquitoes began to bite as they do at dusk. All animals and insects began their nighttime routines during the time of totality, then returned to normal as soon as the sun came back out. The lessons that the average American hopefully learns from viewing the Great American Solar Eclipse were just as important as the awesomeness of the event. Some of the partial lessons include: safe eye protection is imperative in order to view the eclipse. 2. The big difference in partial and full eclipse. 3. Viewers gain inspiration through gathering together to witness nature's majesty and splendor. And 4. One must plan in advance to witness the eclipse in the path of totality. Protective glasses and hotel rooms run out quickly. The lessons that the average American hopefully learned from viewing the Great American Solar Eclipse were just as important as the awesomeness of the event. The popular question that is being asked now is, what discoveries will the next total solar eclipse in the continental U.S. bring in 7 years on April 8th, 2024?
Hello everyone, my name is Deandra Morant, and I'm going to do my research presentation on social media myths on eclipses, the facts versus the fiction. What is an eclipse? An eclipse is basically when the moon comes between the sun and the earth, basically. When that happens, the moon basically casts a shadow over the earth for a period of time, usually like 2 minutes, but it does this for the whole day so that the whole world actually gets a chance to see it. The word eclipse is derived from the Greek word meaning abandonment. In many ancient cultures, they believed that the sun would abandon the earth during an eclipse, which is why that has the name. Fact or fiction? There have been many myths believed over time about solar eclipses and what's actually going on. But as you can see here in this slide, a solar eclipse basically is the moon covering the sun, as you see depicted in this photo. Some of these myths are understandable, and some of these myths are just like, wow, I can't believe you thought that, but I'm going to get into that. Okay, so here goes some of the myths. In the photo right here, we have a dog licking the sun. In ancient China and Korea, they believed a giant dog was eating the sun. In other Chinese myths, they believed it was a dragon actually devouring the sun. But that's not true. What really happened, that's not what it is. They would basically try to scare off the sun-eating demons by making a lot of noise. They tried to do all types of crazy things. In this slide, you see the photo of there being a solar eclipse, and there's a lot of things going on. There's this lady over here making noise. There's these people dancing, and there's even these guys whipping a dog because they're basically trying to make the most noise possible to try and scare off these sun-eating demons. It works for them because, obviously the moon has to move from in front of the sun. And this one is kind of crazy because even in like some African cultures, even still today, they believe that the sun and the moon were fighting during a solar eclipse. So today they still believe that since the sun and moon are fighting, they use it as a reminder to try to tell them to stop fighting, so that they can forgive each other and move forward with their lives and everything like that. The solar eclipse is supposed to signal a time of forgiveness in some cultures, and they still believe that to this day, which is great. Another myth is if you're pregnant during a solar eclipse, that maybe your child is going to come out with deformities, or maybe you'll go into labor, things like that. Many people believe to this day, especially in Hispanic and Indian cultures, they believe that pregnant women are in danger. In fact, in India, the pregnant women are forbidden from going outside during an eclipse. Here are some facts. And a reoccurring theme throughout history about solar eclipse is that the sun produces this magnificent corona or bright light that is harmful, but that's not true. The only way this light can harm you is if you stare at the sun directly before a solar eclipse or during a solar eclipse, because of the moon blocking the sun, the light around the moon is brighter and more visible because it's darker outside because of that shadows that's cast over Earth from the moon. You get that shadow, which is why we see that bright light. The only thing is the bright light is not at all in any kind of way harmful to you. In fact, it's the same bright light that we see every single day. The only difference is that light is not as visible because, we just see the sun as a bright firing ball. You don't really look at it that often. The solar eclipse won't harm you in any kind of way, only if you're crazy enough to look at the sun. In fact, I was crazy enough to look at the sun. It didn't really cause me any harm or anything like that, but I was seeing bright lights everywhere. When I was looking around, everything looked really bright to me. On my works cited page, I did use the NASA website to actually get the definition of what an eclipse is. And then majority of the information I did get, I used it from my research paper. So my research paper, of course, is connected to the class. So that's where all my information came from.
Everyone, I'm Lori Harris, and my research presentation is on the history of human observation of eclipses. It's called From Dragon to Shadow. Many Americans were incredibly lucky this past August to witness something rare for most people in their lifetime, a total solar eclipse. The eclipse that occurred on August 21st, 2017 was the first total solar eclipse to cross the entirety of the United States from coast to coast in 99 years. As with countless eclipses before it, the Great American Eclipse, as it was known, caused virtually every human in its path to stop and gaze skyward, with our protective glasses, of course. An eclipse, especially a solar eclipse, is a source of great fascination and intrigue. Today we know that a solar eclipse is caused by the shadow of the moon when it and the Earth line up in just a way that casts the moon's shadow onto Earth, and from the vantage point of those in the right spot, completely blots out the sun. We know this today thanks to centuries of observation and study by our ancestors. But what led up to this understanding? What could early humans have felt and thought when they witnessed an event that must have been terrifying and confusing to people lacking the scientific knowledge and understanding we have today? How did our collective history of observing this phenomenon lead to what we now know and understand about the cosmos? Archaeoastronomy is the science that seeks to answer these questions. It is the exploration of the ways in which ancient civilizations studied the skies above, how they did so, and how it may have affected their cultures and beliefs. These studies help us understand specifically how we have perceived the phenomenon of eclipses over time. Two examples are the Chaldeans of the Babylonian civilization and the ancient Chinese. The Chaldeans were the first to use what we now call the Saros cycle. We have evidence on the clay tablets they have left behind, shown here in this image. They have cuneiform writing which depicts their measurements of the motions of the heavenly bodies and even predictions for the occurrence of eclipses. Archaeoastronomers have found that their predictions were in fact accurate, despite the lack of modern math, physics, and telescopes. The Chaldeans actually used a form of what we would call calculus today to measure the movements of the planets and the moon that they saw in the sky. Meanwhile, the Chinese evidently regarded eclipses with fear and a sense of doom, believing they were a bad omen for the currently ruling emperor. They believed a giant dragon was taking a bite out of the sun. In fact, the Chinese word for eclipse is shi, derived from a phrase meaning to eat. As civilization progressed, so did human understanding of the previously unknown. Of the Greeks, we know that it was Aristotle who first proved that the earth is spherical. He did this through his observations of a solar eclipse. A few hundred years later, Ptolemy documented his observations in his work, the Amalgest, which indicate that he knew and understood not only how to track and predict eclipses, but he understood what caused them. An excerpt from his book is shown here. Most astronomers agree the modern age of astronomy began with the first ever photograph taken of a solar eclipse. It was taken by astronomer Warren de la Rue on a British expedition to observe the eclipse of 1860 that crossed through Spain. Shown here, you can see how this feat not only helped usher in the newly budding age of photography, but it also offered for the first time scientists the chance to study and analyze an eclipse as well as details about our sun. They were able to observe the corona for the first time, and they were able to measure the sun and its size more accurately. The passing of the moon in front of the sun, blocking out its bright, blinding light, has allowed us to make many advances in science. Just a couple listed here. Once the corona was discovered and understood, examination of its rays revealed amazing things. In the late 1800s, scientists Pierre-Jules Janssen and Norman Lockyer studied the spectral lines they could see during an eclipse. They discovered a brand new element, helium, which they named after the sun god Helios. This was the first time the composition of another world was revealed. One of the most remarkable advances that came through observations of an eclipse is the confirmation of Einstein's theory of relativity. This was done in 1919 by Sir Arthur Eddington. He was finally able to prove through observation and measurement of the stars behind the sun and how their light deflected around the sun to meet the eye below that Einstein's theory was correct. This is because the deflection of the light was proof of his theory of relative motion. On November 6, 1919, the theory of relativity as we know it today was announced, helping solidify Einstein as one of our most famed scientists of all time and replacing the previously held beliefs of Newtonian law. This is an image depicting the light deflecting around the sun, which was what proved Einstein's theory of relativity. You can see the actual position of stars behind the sun. The telescope placed on the Earth represents our eyes and what we saw or what we see during an eclipse. And you can see the apparent position that we would see due to the deflection of the starlight around the sun, which would only be seen during an eclipse when the sun's brightness is dimmed. The future is bright. With each opportunity to study the things revealed through a solar eclipse, we are able to learn more and more about our sun, our world, and the universe around us. We will continue to expand our human understanding of the cosmos for many generations to come.
Good day, class. My presentation is on solar myths being spread around social media. The origin of these myths tend to be based in religion and plain misinformation. Some of the myths in the one we will explore today are the former dispute over the sun's place in the solar system, the belief that the sun is only 6,000 years old, the belief that the Earth's placement changes during the different seasons, the belief in the religious phenomena of a lost day, and most personally surprising is that the sun is not actually yellow. As we have already studied in this course, for much of history, the placement of the sun was a matter of speculation. Even before that, the sun was regarded as a bad omen or as a god. When the study of astronomy began, however, and society had moved toward monotheism, this idea was discarded. The study of astronomy brought about a logical fallacy, however, as Ptolemy speculated that the Earth was the center of the galaxy. Galileo, using his updated telescope, observed otherwise by viewing light hitting the other planets. Though this myth is not widely believed in this age, it was the first modern solar myth. Perhaps the most popular of the myths about the sun, especially in terms of religion, is the young Earth creationist theory that the sun and the rest of the galaxy, and in their belief the universe, are only 6,000 years old and not the billions that has been proven time and again. While those beliefs have been around as long as monotheism, social media aids in the perpetuation of this myth. Ken Ham, a young Earth creationist, has created a list comprised of what he calls facts that support his theory and has been discredited by scientists, with anthropologist Dan Arrell taking the points one by one to explain their logical fallacies. Especially when it comes to the faint sun paradox, a theory held mostly within this young Earth creationist ideology. The faint sun paradox exploits incomplete scientific discovery and, according to Arrell, is as close as they come to actual science. Because of the hydrogen that makes up the sun that should be gradually heating, Ham theorizes that the sun and Earth should have been essentially too cold to exist billions of years ago. This theory is still being studied, and claiming that the incomplete science is a validation for a belief rooted outside of science is completely irresponsible. But people believe it, especially when they see it shared by trusted fellows on social media. Yet another religious myth is the belief that comes from the Bible of the lost day. In the Old Testament, there was a day when the sun remained entirely still, essentially causing a day to never occur. There is no evidence that this occurred outside of the Old Testament. and believers in the myth have perpetuated that NASA has taken an interest and has either found proof or is searching for proof, depending on the source. NASA, however, has no interest, as due to how far back in time this would have had to have occurred, there is absolutely no way to prove it. Unfortunately, this also somewhat fuels the myth, as there is also no way to disprove it. Scientists typically agree, however, that even if such a phenomenon did occur, it would bear no scientific weight and has no effect on present day. A myth rooted more so in plain misinformation is the belief that the Earth is closer to the Sun during the summer and further from the Sun during the winter. This myth is based slightly in fact. The Earth is slightly closer, but only by fractions of degrees, and that is mostly attributed to the tilt of the Earth and its position of the Sun hitting or not hitting the surface. In fact, the hottest point for us, our summer, occurs when our hemisphere is pointed away from the Sun on the elliptic cycle, and vice versa for the winter. Again, this myth is almost completely based on a logical fallacy and incorrect misinformation. That said, believing the myth can damage one's understanding of seasons. This pictogram shows how the tilt of the Earth affects each hemisphere's season and temperatures. Perhaps the most surprising myth is something that we have learned from an early age. The Sun is yellow, or so we think. The Sun actually contains all the colors, meaning that it is truly white. These colors are responsible for rainbows and the appearance of a blue sky. Rainbows are a refraction of all the colors present on the Sun, and the sky is blue because the shorter wavelengths that make up the blue color are more visible in the upper atmosphere than they are in the lower atmosphere, which is also why we mostly see yellow, orange, and red. In fact, the fact that most of us in this class would say yellow rather than any other color is mostly cultural. In America, we are taught the sun is yellow, but in other countries, such as Japan, they are taught that the sun is red. This graphic shows a simple rendering of the ways in which sunlight hits us and hits the atmosphere. Now that the myths have been explored, it's time to view the statistics. According to a study completed in December of 2016, 23% of adults admit to sharing false information. Going even further, results saw that 14% were aware that the information was false when they shared, and 16% found out at a later date. These stories either aid to serve an agenda surrounding their beliefs, or they were embarrassed to find that they were incorrect and never corrected themselves. Dartmouth College and University of Exeter concluded that unless the facts are completely accepted by the subject, even though the individual may know of its falsehood, the myth may still carry some weight to the subject. Furthermore, as can be seen from the graphic, from 2011 to 2012, there was a 7% increase in adults who get their information from social networking sites, in contrast to the 4% increase in natural search engine results, which is thankfully the majority source of information, though the reputability of the sources chosen from the search engine is unknown. In conclusion, many of the myths are perpetuated to serve a religious agenda, meaning that the source should always be checked. Unfortunately, because many people are either trusting of their friends and family on social media or are completely refusing to check facts, these myths continue to be spread. Any reason for disregarding fact is unacceptable. Social media can be a wonderful tool for gaining knowledge and information when used correctly. The inverse, however, of spreading falsehoods is dangerous for our own knowledge. Thank you, and thank you for my sources that I used in writing my paper and in using in this PowerPoint.
Hello everyone, my name is Andres Herrera, and I'm going to talk to you guys about the fact that the sun has on the surfaces and atmospheres of the terrestrial solar system objects. So to start out with, I'm going to mention what a terrestrial solar system object is. A terrestrial solar system object are bodies that obtain solid surfaces in which one could stand on top of, meaning that the terrestrial solar system object is hard-surfaced and they're Earth-like. Being an Earth-like object, they are made up of rocks or metals. The terrestrial planets obtain a molten heavy metal core and also have many features that are knownable: volcanoes, craters, and valleys. And in this presentation, I will be talking about the fact that the sun has a terrestrial solar object. And in those objects I will be mentioning are the inner planets. Those inner planets are the closest to the sun, in which they are Mercury, Venus, Earth, and Mars. So to begin talking about the effect that the sun has on the terrestrial planets, I will be talking to you guys about the planet of Mercury. Mercury is the smallest and least massive planet of the terrestrial planets, and it is the closest towards the sun. It experiences higher particle fluxes and UXV radiation than any other of the planets. The high-octane winds that come towards Mercury has a long-lasting impact on the surface. With the high-impact surface on the planet, there are crashing charged particles that are also included in the planet's surface. The particles that are crashing into the planet's surface and the heat that comes from the sun produce kick-up material from the outer layer of the planet, sending it flying it all over space. And some of the heaviest atoms that drift back to the surface, while the lightest are affected by the gravity and by the pressure from the solar photons. This will obviously cause a tenacious atmosphere known as exosphere, and it's an atmosphere that is relatively low to very thin, and it causes a change in temperatures between burning and freezing. Mercury is also a dense planet that's made up of mostly iron and nickel with an iron core. It has relatively no magnetic field, about 1% of Earth's magnetic field, and the surface of Mercury has many deep craters and is covered by a thin layer of tiny particle silicate. So the effect that the sun has, it's not possible to host any life whatsoever due to its thin atmosphere. The second planet I'm going to talk to you guys about is on the planet of Venus. Venus has a thick, toxic, carbon dioxide-centered atmosphere that absorbs the heat and makes it the hottest planet in the solar system. The composition causes a runaway greenhouse effect that heats up the planet even hotter on the surface than on Mercury's, which is the closest planet to the sun. One interesting aspect when I was learning about Venus was how roughly billions of years ago that Venus's atmosphere was like Earth's, with liquid water on the surface. What happened was runaway greenhouse gases may have caused the evaporation of the water on the surface and made a rise on the levels of greenhouse gases. Unlike Earth, Venus does not have a magnetic field. Venus's ionosphere separates the atmospheres from the outer space and the solar wind. Venus only has an induced magnetosphere that was created by the sun's magnetic field carried by the solar wind. Due to the lack of the magnetic field on Venus, the solar wind penetrates really, really hard into the planetary exospheres and causes dramatic atmosphere losses. The clouds on Venus are very, very thick that the surface is really not visible in visible light. Because not a lot of sun reaches the surface, Venus has no significant seasonal temperature changes. And much of the surface on Venus is filled with volcanoes, deep canyons, and few impact craters. The next planet I'm going to talk to you guys about is Earth. Earth is the third furthest planet away from the sun and is the planet that can sustain life and obtain water. The gases that we breathe in every day of nitrogen, oxygen, and the other small amount are gases that keeps us away from the powerful blast of heat and radiation that comes from the sun. Those gases actually heat up the planet during the day and cool down the planet during the night. Earth has a strong magnetic field, unlike Venus and Mars. The magnetic field creates a magnetosphere that surrounds the planet and sidetracks the path of the high-energy charged particles that are coming from the sun. Therefore, the magnetic field protects the Earth's atmosphere from being stripped away into space by these particles. The solar wind that's interacting with the Earth's magnetic field transfers some of the energy that's being obtained by the sun into the upper atmosphere in the polar region, which results into auroras being visible at high altitudes. The effect that the sun has on Earth is less uniform than on Mars and Venus, but supposedly the net loss rate is about the same in terms of momentum. Earth has atmosphere and that's about 300 miles thick, Most of it's within 10 miles of the surface. This obtains a rocky surface with mountains and canyons with a heavy metal core. The final planet I'm going to talk to you guys about is on the planet of Mars. Mars is the fourth of the inner planets and is the furthest away from the Sun. Mars is a very dense planet and it has a smaller magnetic field compared to Earth, which reveals that it has a solid core rather than a liquid core. It was once thought that Mars could support life, but throughout time, Mars ended up being dry with no source of liquid in the planet. The mission of Maven was set out to reveal why that occurs. Part of the reason has to do with Mars's light gravity, coupled with the lack of global magnetic field that left the atmosphere out there to dry and be consumed by the solar wind. The streams of particles from the sun, the pressure of the sun, absolutely stripped the molecules from the atmosphere and that thinned it out. So from once a thick atmosphere, Mars is now a thin atmosphere that's 100 times thinner than Earth. It's composed around 95% carbon dioxide. The Sun had to do a lot with the transformation of the planet of Mars, as having such high amounts of radiation and the exposure of cosmic rays and solar winds with the frequent blast of solar flares led to the Mars surface to dry up once from being a liquid planet. And Mars has the surface that has many mountains, but very old and filled with craters. As I conclude my presentation, I will leave you guys with this side-by-side comparison of the four terrestrial planets and the impact that the Sun has on them, the difference of temperatures that we've seen from all the planets and the components of the atmosphere and compositions, the type of gases that exist in those planets. Thank you very much, and hope everyone enjoyed this presentation. Thank you.